Okay, well, welcome everybody here, and I guess, okay, mine is green, blinking green. Got to remember the technology. I guess we're webcasting this one as well. So glad that you guys could join us, and my name is Doug Paulson, and I serve as STEM Integration Specialist for the department, and have been with the department about 3 years. Prior to that, taught elementary and middle school math and science, and my colleague?
John Olson, been at the department for about 4 years. Prior to that was in St. Paul Public Schools, middle school and high school science.
So today we, again, want to talk a little bit about next generation science standards and kind of the research that comes from that. And so I'm going to start off here leading us through an activity. I'm going to try to balance a couple things at a time here. We're going to pass out, Don, do you want to pass out the syringes here? Pass out the syringes here, and want you to do a little bit of an investigation here. And the first thing you're going to do is you're going to fill the syringe with as much air as possible, so kind of pull the syringe out, and then block the end of it with your finger and push it as far as it will go. Think about what's happening to the air in that plunger there. Okay? Once you've done that, you can kind of close it up a little bit. Again, cover with your finger and pull it out as far as it'll go. And again, think about what's happening to that air that's inside of that. Okay? Talk with the people around you, and we have a real short time, so this would be normally an activity we spend about 20 minutes alone on. We're going to spend about 2 minutes on here. So talk with the person next to you. What's happening to that air as you push that plunger in or as you pull it out? And you'll probably have to kind of hand them around a little bit. See, I don't know where you left off here. So what's happening to those air molecules? Talk with the people around you. Good opportunity to also introduce yourself. And I think that you have, John handed out a piece of paper. You can either do this through discussion or you can do this as a drawing. I want you to create a model. And again, that model can be a verbal model where you're talking it out with the people around you. You might want to draw a model. You can see on the left-hand side there, you know, some circles you might want to fill in terms of what's happening to the air particles in there. Try to create an explanation of what you think is happening within that syringe when you push that plunger in and as you pull it out. So what's happening to those air molecules in there? Again, however you want to model that, but to put it into some way to explain the phenomena with someone other than your partner. Take about, again, 30 seconds on this one. We're going to really squinch this together, much like the plunger of the syringe there. Right. I told her we'd ignore those cuttings. Turn to someone different that you have not talked to and explain your model to them. So behind you, across the aisle from you, someone different that you've talked to, explain what you see as your model. This is part of the networking, part of the STEM network. So we often talk about modeling, and I'm going to kind of pull us back together again, and I know, again, it's much like that air in that plunger. We're pushing this tight, and the time we could spend a lot more time with this. With this modeling, we're able to start to create some of our ideas around air pressure. Okay? And we see this from students as well. As they start to model through drawings, through representation, through some of their mental understandings of the concept, we're really able to start to distinguish what is the student thinking there. Okay? We see here that we have students that have put dust in there. They think that there's something happening within that plunger where there must be some dust. Or when they push that plunger, there's got to be some wind. Okay? Again, that idea of movement. These are misconceptions that students start to develop and start to think about that we oftentimes are not able to pull from our students because we will teach them ideas of air pressure as facts and, hey, you need to remember this for the test. But it's really that student thinking that we want to pull from this. And this is one of the thoughts and one of the ideas that is really essential from the next generation science standards and from the research that comes from that we want to kind of go through today. So I'll pass this over to John.
Okay, now, traditionally we probably would have called this kind of an activity an inquiry activity. You've probably heard that phrase a lot. And when we've been working with our Minnesota standards, we've really emphasized that students learn through inquiry. But when we look around and ask teachers, what is inquiry, what does it look like, we hear a variety of expressions and very much many ideas. So people have been looking at this very closely. What are the ways that our students learn and what are their skills? And so recent research has said we need a richer understanding of what inquiry means. We really need to look at these a list of 8 practices. And if you look at that list, you'll see some that are very familiar with what we've called inquiry. Asking questions, carrying out investigations, forming conclusions. But there are some pieces in there that look a little bit different than what we've done before. That number 2, developing and using models. It's not something we've talked about a lot. But really that was the emphasis of the activity we just gave you. To look at your mental model to figure out what's going on. We want the kids to be visualizing what's going on. And you probably saw in the student examples that the kids have a little bit of trouble with that. We worked hard for them to get the idea that air is something. It's not just an empty space. Okay, so they got that idea of something, but now they're having a trouble with the idea of there's nothing between the something. They want to fill it in with dust or with wind or something like that. And so helping our students develop those mental models and carrying them forward and finding the limitations of their models is a real challenge for us. There are several other things that you'll see on that list. You'll see a lot about communications, evidence, presenting evidence in that. That sounds a lot like the Common Core and Minnesota standards about claims with evidence. So these are some of the practices we're starting to emphasize. And that research has said that there are really 3 dimensions that have to go together to help our students learn well. One of these practices, both science and engineering. Another is a set of concepts that we call cross-cutting concepts, like patterns, like scale and proportion, like cause and effect. These are things that we think should be woven together for good student learning. Where that research has been pulled together is in a document called the Framework for K-12 Science Education. This has been kind of a groundbreaking document that came out summer of 2011, which pulls together those 3 dimensions that we talk about, and also says what are the main core ideas that our students should learn. What are the most important concepts to develop? And based on that document, our states have come together. We were part of one of those 26 states that were involved in developing a new set of standards called the Next Generation Science Standards. And to give you an idea how that pulls together, we have an example of a comparison between Minnesota standard and a similar content in Next Generation.
So you'll notice a couple things here. First of all, the real push is that students can learn some of these concepts at earlier ages. So you see that, this really comes from, in Minnesota we have this kind of in one of our 6th grade physical science standards. Pure substances can be identified by properties which are independent of the sample of the substance, and properties can be explained by the model of matter that is composed of small particles. So you can see some there. We're talking about the modeling. We're talking about this idea of air. With the next generation science standards, you'll notice that it is bringing together the 3 strands. So we have develop a model. Okay? This comes from that second practice. Okay? Again, what students are expected to be able to know to do as scientists, more than just this ambiguous inquiry that we may or may not have similar understandings of. To describe that matter is made of particles, okay, that gets into that core discipline idea, that are too small to be seen. Gets into the cross-cutting concept of scale and proportionality. Okay, that cross-cutting concept is something that can be seen in the physical science, a life science, and earth science, that really goes across and helps the students to weave that fabric of understanding within science learning. Okay, so you can see that as we start to make some of the shifts in some of our understandings in terms of some of the practices, we're really doing a lot of the content and really focusing on, for our teachers, what are those practices, what are those cross-cutting concepts, and how can we help students make meaning and understanding as scientists. And so that's really going to be part of our goal within this. And what you can see in the differences between what we have in our current Minnesota standards as revised in 2009 and the next generation science standards, which just came out in its publication here this past month. Correct. So the top one is our Minnesota 2009 standards, which is a 6th grade standard, and the bottom is next generation science standards, which is a 5th grade standard, or in this case, they refer to them as performance expectations.
In Minnesota, our standards are organized around 4 strands: physical, earth, life, and then we have a 4th strand that's called nature of science and engineering. In the next generation of science standards, they're trying to pull that nature, science, and engineering together with the content areas. So you'll see development model, that's one of the practices, that would be the equivalent of our nature of science and engineering woven into this. The other thing that's a little bit different is that in the next generation science standards, they're calling these performance expectations. So they're not saying that this is an instruction that you will see on March 15th. They're going to be doing that particular performance idea. They're going to be able to be assessed that in some kind of performance expectation that you do that. So it's up to the teacher. The teacher doesn't necessarily have to match that practice with that core idea. They can use others, but the students should be able to do that as a demonstration that they understand.
That's one of the reasons why in Minnesota we're really focused on those practices right now. So teachers are able to have that toolkit of ideas so that they have that art of teaching that comes into this.
So in Minnesota, we have, by statute, a cycle of when we adopt standards. So by that cycle, our latest standards were written in 2008-9. They were implemented in 11-12. And our next time to revise standards is 17-18. So unless statute changes, that's when we will be making this decision whether we'll be going to next generation science standard. But as Doug mentioned, we found that the research underpinning it is very strong and very supportive of our Minnesota standards. So we are already starting to do professional development and encouragement around many of these practices and cross-cutting concepts to get people kind of ready for it and also to build our student learning. So, kind of take away from Minnesota, what are we hoping to do? We're doing in professional development that backs up these core ideas, these concepts that have come out that we know are good for learning. We're trying to take a look at what that looks like for our students, try to think about what does assessment of those ideas look like, and we're being in conversation with other states as they go through this process as well. So that's kind of our goal as we go forward with this. So here's a little bit of contact information. We'll give some time for questions here. Our contact information. The framework for K-12 education, the one that we referenced here, is available as a free download from the National Academy Press. So if you go that, you can download that and get that on your machine. One of the research pieces that came ahead of the framework was a book called Ready, Set, Science, Translating Practice into Classroom Application. That's an easy read. It's a good read for teachers to be used, and it's not only K-8 really. We've also collected those resources around this at our Minnesota Frameworks website, the one that we use that was put up on the PowerPoint earlier by Peter Lindstrom. So that's another place where we're collecting resources. So, what questions do you have, or what comments do you have? Yep.
We really have two different parts, you know, from the elementary side, and being a former elementary educator, you know, I agree with that. You know, the first part is the content, and having a background and understanding within the content. And we have a number of great programs throughout the state that have been really working and focused on that, and continue to connect with schools. The second aspect, I think, that really has an opportunity is that pedagogy in terms of the instructional approaches. And I think that oftentimes from an elementary background, they are intended to be jacks of all trades, masters of none kind of thing. And that's sometimes, for teachers, a difficult place to be at, because they want to be able to help students know, and by knowing, they want to give them the answer. If we can go back to the slide on practices here, I think that you know, one of our opportunities is to really start to engage in these conversations around the practices. And so as the teachers are going into those classrooms, what are the tools that they have to really teach that understanding, and recognize that they don't necessarily have to have all the answers, but they need to start to engage the students in understanding as a scientifically literate person. And so we see here pieces in the bottom there, the 6th, 7th, and 8th one, constructing explanations, engaging in argumentation, obtaining information. We see a very close correlation to our English language arts standards, which we've adopted the Common Core within Minnesota. We see opportunities now we have at the K through 5 that are to be embedded within that. And from the 6th through 12, those standards that are pulled out in science and technical subjects. So we want teachers to start to take a look at those from the English language arts, so they have that opportunity as integration. And coming from a STEM school, that's obviously a focus for you. We see within the analyzing, interpreting data, and using mathematics, we're moving away from having to have the formula that students are utilizing to show that they can plug the numbers in and demonstrate the science, to really, what is that mathematical thinking? So it gets them into that explaining what is actually happening here from a mathematical sense. So again, getting that integration and getting into that real-world application that really our Minnesota standards call for as well. So again, that opportunity for integration. So for professional development, both at an elementary level and a secondary level, it's really focused around what do these practices mean in the classroom, and how can I utilize these as a toolkit so I'm able to engage my students in meaningful ways. And so that's really the opportunity we have around professional development. This afternoon, there will be a session on the Mathematics and Science Partnership that I'll be doing, which is our statewide program for professional development that we've utilized a lot of these strategies for.
If you can't make it to one of our workshops or the things going on around there, I really recommend the resources from the National Science Teachers Association. They've written in their publications an article about each of the practices, which are archived on the NSTA website. They have a webinar about each of the practices on that. They've also put out a small document that's called A Reader's Guide to the Framework. They go chapter by chapter with discussion questions. So that would be a great PLC activity if you wanted to use that in your building. Pick a chapter or a section each month or whenever you meet, and use that as self-guided professional development.
Other questions? Did we answer your question?
National Science Teachers Association, it's nsta.org/NGSS, and you'll get to all their resources related to that.
Who knows that both exist?
The mechanism that we've been using to get it out is, number one, the membership of our Minnesota Science Teachers Association, and then we have a monthly newsletter that goes out to district contacts, who hopefully will spread it out. So keep that going, so if you're not getting it, you don't have access to it, let me know and I'll add it to your list. Give me your email address and I'll add you onto that.
I think a lot of it comes, also word of mouth. So the teachers are sharing their best practices with each other, and with the local control districts in Minnesota, there's always that kind of grassroots type of efforts with any type of new research that comes out. And I think that, as a profession, we need to encourage teachers to understand and know the current research, and this is one of those opportunities within the sciences. That's always a challenge, and always willing to have other partners on that as well. So thanks. Steve? Close, legislature. No, you're right. I think that that's where it's great to have partners with SciMath-Min, great to have partners with the High Tech Association, great to have partners with many of the organizations that you all represent, because you're right, there is that conversation. And how do we bring leadership on there? And it's great to have administrators from principals that are here that are supporting that effort in the classroom, and that obviously is a key aspect as well. So you have the teachers, but you also have all the other avenues, and that really comes through some of our partnerships and collaborations that will continue to work on that. And we've always appreciated the Humphrey School as one of our partners on that as well. Well, the framework for K-12 science education is a document that comes before the standards. This is the research on what best practices are. So as we start to talk about what we want to see in the classroom, what are kind of the best practices that are, in general. So as we take a look at these practices here, as we take a look at utilizing those cross-cutting concepts, that's kind of the formation for standards and instruction just in general, and what we would expect to see classroom teachers thinking about and reflecting upon in the classroom. The frameworks, which is on our Minnesota STEM Teacher Center, is really about taking standards into practice. So they're focused much more on a grain size of the standard into practice. So what does that standard actually mean? So what does it mean for this idea of air pressure? What do we want students, what's the big idea behind that? So getting into those instructional decisions on a daily or a weekly type of a schedule in terms of what are the resources I'm using, what are some of the ideas, what are some of the understandings I need to have on this particular concept. That's where the frameworks, our online piece, is used.
So is it really a distinction between the Minnesota frameworks are all about the content and the national frameworks are more about the process, or is that not really a fair distinction? I mean, I recognize
Well,
they're at a different stage of development, but I'm trying to figure out how to describe it or to urge.
sure. Get some touch on?
The framework document from there gives you sort of, here's the broad ideas, and here's the other thing it does a good job of, here's the learning progression. Based on this big idea, here's where they should be at 2, 5, etc. The Minnesota Frameworks website is organized by standards. The teacher will go there and say, I'm working on this standard. Here are some activities, here are some resources, here are some understandings about that I can use as I get ready to teach. And hopefully people aren't doing that the night before instruction, otherwise they'll get distracted and go all over the place. So, you know, it's really helpful at the unit development kind of level for that. One of our goals is now to bring some of the ideas from the framework national document into the Minnesota framework, so we can say, as you look at this concept, here's some broad ideas that the framework says about big understandings for that. We have a section in the framework's website now that is an overview which goes into the background behind it, and we want to bring that into it. That's one of our goals for an activity related to this.
So, you know, so I think that, you know, both are really important for the instruction. And, you know, our colleague Sam Shaw back here from South Dakota said something to me when we were down at the National Science Teacher Conference that was genius. And, you know, the fact that, you know, when we take a look at this current research of understanding in terms of classroom instruction, both from our the national framework as well as the frameworks. You think about the teachers that have not had a chance to implement that, and you think about it from a different profession level. Think about doctors. If they are utilizing strategies that were proven 20 years ago and they decide to use on my patient today, if I was going in there, would that be a good thing? You know, that's malpractice, right? If there's a current strategy, the current research that shows that there's a better way of approaching that. And from teaching, we don't spend enough time in either parts of this. So both research pieces, the national framework as well as our state frameworks, are both important for teachers to be embedded in. So they're really familiar with and understanding, you know, what are those best practices that they should be thinking about in their classroom. Mm-hmm.
And so, you know, they didn't ask our permission before they used the framework in the national. So, the systems do things that are really different. Yep. I mean, you explained the difference.
Right.
In terms of it's just the same word, it's not.
Right. Yeah, it's always challenging when you have similar words or the same word in this case. Carlos? Yes, we have analytics that we look at on a regular basis. You know, as far as top of my head, about 60,000 views in there. Yeah, and we are able to track down onto a district or a city level, and occasionally we'll have. I've had, I think, 2 or 3 calls from district administrators saying, you know, do we have any ideas of who's using or how many people are using it from my district? And we're able to go to that level. You know, as far as, you know, informing us, we certainly have used that to inform where we need to do some workshops and outreach from it, and where we've seen gaps in terms of use. And really, that first year was a lot of our strategies based upon those analytics. Yeah. Eva's given a red card. I couldn't quite remember if that's stop or if that's 5 minutes. That's that. We're done. I told her to ignore it anyways, but thank you for attending. If you have other questions, this is a really quick workshop. We have planned this summer on June 21st. We have a morning session, a 4-hour session that we are going to go much more in depth with the practices with these ideas. So if you have teachers, would certainly encourage them to attend that. And of course, we're always willing to work with your districts and your schools as well. So thank you, everyone.